on Divenn2 or Divenn version 2.0. My name is Dane Zeeb. I'm a bioinformatics programmer at Boston Children's Hospital that's worked extensively on this new release of Divenn, and I'll go over some of the new features and kind of the general use of the site. So jumping into this, we have the homepage. I've selected some examples here, but if we want to choose species, we have we now support up to 30 species, and a lot of these are lesser model species, which can be very useful to researchers working with these species. Our database now supports visualization and kind of description of genes within all these species, and if it's available, we also provide Go and KEGG enrichment for them as well. So for this, we're going to be using Arabidopsis, chosen here. We also support a new gene ID type, which is Ensemble, but we also support uniprot and NCBI IDs for our sample data. We can paste text data or upload a file here. We also have a new option for cutoff values. We can do a custom log fold change cutoff value. So if we see here, we've loaded sample data. We have the gene ID type, the up or down regulated distinction with the 2s and 1s. But if we were to do the log fold change, we could set up a cutoff value. We also have sample data for that, but this is kind of what the sample data would look like. For this presentation, I'll be using the default value. And for each of these gene ID types, we can reference a file on the sample data for your specific species. If you have a species and you're wondering what is acceptable, we can click on this ID table here, and this will load this page. Here we see the kind of the species code, common name of the species, and then we have a list of example IDs for Ensemble ID, uniprot, and NCBI. As long as your gene ID looks like any of these IDs for these different species, we'll be able to handle that with our database, and also for Go and KEGG enrichment if available. We also have another view, kind of at a glance, of what's available for each species for Ensemble, uniprot, and NCBI for the Go and KEGG enrichment. In general, NCBI is useful and can be used for Go and KEGG enrichment, but in some cases, Ensemble and uniprot are also available. The only problem with this is that if you choose to do Ensemble or uniprot using any species that don't have a supported key type for Go and KEGG enrichment, mapping will be performed, and we may lose some gene IDs from your list, but it still can be performed. Okay, going back to the home page. Once we have all this information, we've loaded our data, we have all of our experiments, we can hit submit. And here we get our visualization. Looks pretty similar to Divenn, the original version. We can move our visualization, zoom in, zoom out, but we have added new features, starting with this control panel over here in the upper right-hand corner. We can control our graph directly from this. We can hide labels or show labels, show gene numbers specifically, hide them as well, and then we can also summarize groups to show a without node view of all the genes in each of the node groups between the experiments. We can also hide that. We're also able to change the color. So if we want to change experiment 1 from purple to, let's say, black. Do that. We can click change color, redraw the graph with that as black. Additionally, we can change the shape of the nodes. So if we wanted to change the shape of upregulated genes, for example, we can change all of those to hexagons. And then we click change shape, and now all of these are hexagons. We also have stars, triangles, rectangles, etc. If we want to change that back, all we have to do is go back to circle, change shape again. Here we have that. So we have greater control over the visualization, and color changing of each of these different portions of the visualization. We can also change the font size for the labels and for the experiments names. So from here, we also have the all genes detail, and we have a save option for this visualization, which will just save this visualization for later and download it from the web browser. But with the all gene details, we will come back to this. These will produce tables, which I will cover shortly. So from here, we can also check a single node. For example, this gene here, if we wanted to, we could right click and show a lot of new options. One, we have show label. We can see the gene ID here. We could show the symbol if it's available. So this is CM5. And we've added a new table for gene details. Here we have the gene detail, the specific gene detail table. We have the original ID, and alternative IDs for UniProt and CBI, and then a short description. This is where a pathway would be listed if this gene is involved in a pathway. And here's the Go information, Go ID, description, and the category here. From here, we also have this button to show the gene group details, so everything within the group that this gene belongs to, we can show in a table. Or we can right click, say if we wanted to do these 96 overlapping genes, right click that and do gene group detail. And we can see all of the details for the genes in this group. We can also see that we have links to the pathways that they're involved in. If we were to click on this, this will take you to an external site to show the pathway and explore further details about that pathway there. Back to our site, we could load all, and we can then see all of the genes in that gene group. But going back up to the top, we'll see we have 3 buttons here. One is to export this table, so it'll show all of these genes in this table in a text file, or we can click on these 2 buttons, which will take us to the KEGG pathway enrichment and Go enrichment tables, respectively. I have gone and pressed these buttons on different screens. If we were to press this button, for example, we'd be sent to a loading screen. These 2 functions take anywhere between 30 and 90 seconds to complete. They're completed here. For example, this is the KEGG pathway enrichment results table. And this is performed through Cluster Profiler. And we can see that we have 3 detected KEGG pathways here. Again, we can click on the links and it'll take us to the KEGG pathway site to explore the pathway more if we want to. You can see that. And we can see some more detailed information about the results here. And we can export the table using this button, and we also provide an automatically generated bar plot for this information. So here we can see we have color scaling for the p-adjusted value. We have the gene count for each of these pathways, and we can choose the different color scales. So if we want to do, instead of red-blue, we can do blue-red, and it'll change the color scales accordingly. And for the Go enrichment table, we can see here that this is a little bit more sophisticated. We have tabs here for each Go category and all of the categories in one table. We can see kind of a table that is similar to the KEGG pathway enrichment table with the results here. If we want to see Go biological processes, we can click on the respective tab and we can see all of the genes or all of the Go IDs involved in that were detected from that enrichment analysis. If there's none, this will be just a blank table. We can see we have 2 different categories that are represented here. From here, we can also get similar bar plot visualizations. Here we have for all of the Go IDs, you can see the gene count and the p-adjusted value with color scaling here. If we were to just do biological processes, and there's nothing for cellular components, molecular function, here we have another bar plot. These will all be generated automatically. Okay, going back here, now we see that this is opened, same view that we had before. If we click out of here, we can now see the all gene details. We have added these two functions to first take in reference all of the gene IDs that are input from the sample data and reference that against our database for any of these species. We have first, if we want to look at this, pathway details. Very quick, generate a table at the bottom of the screen with each of the gene IDs and which pathways they're a part of, if they're up or down regulated in each of the experiments, or if they're not there at all. We can see that here. And again, we can click on any of these to be taken to external sites to view those pathways. We can also get a similar table with gene ontology details. So populate here, we can see the gene ID and the Go ID that it is involved in with the Go term, category, and if it's present in any of these experiments. Going back to the pathway detail table, here we're showing 50 entries. We can see here we have a total of 21. If we wanted to subset, we can do that with these checkboxes here. So say we wanted to show only 10 of the 21 entries, we have a much smaller table. We can click on all of these, or we can click them individually, depending on which ones we want. And then we can click only redraw selected, and then redraw the whole graph. And here we see the experiments with each of those ID types, or with each of those gene IDs in their respective groups here. And from here we can do similar things just with this new table. Here we show these are the 10 entries. If we do gene ontology table, we'll only have the gene or the Go IDs that are involved in those genes specifically. So that's pretty much it for the upgrades that we've had to Divenn in the second version of Divenn2. For further reading, just go to the GitHub. There's more details on how we make these visualizations, and there's info on the ID mapping flow specifically, which would be good to check out if your gene IDs are not directly supported as key types for any of the KEGG or Go enrichment. If that is the case, we will have to perform ID mapping using our database, and more details about that are on the GitHub specifically. So yeah, thank you for this training. If you have any more questions, raise issues in our GitHub, or email us at our email addresses listed on the README.